and welcome to another beginner's guide to machine learning with ml5.js. In today's video, I am going to look at the BodyPose model. Now, you might be thinking to yourself, don't you already have a whole video on your channel about PoseNet and pose classification and all that stuff? And yes, I do. But there's a new version of ML5, updated models, the function names have changed, the API has changed. I'm going to show you all the new stuff. With any machine learning model, the first things that I always want to think about are what are the inputs and what are the outputs. In the case of the BodyPose model in ml5.js, the input is an image. Now, the image is something we're going to load in P5, and it might come from an image file, it might come from a camera, and it can actually be of any size and resolution. The actual underlying model that I'm going to get to in a bit, what is it, has to receive the image at a particular resolution. But this is something that's going to be handled for us behind the scenes. So far, this looks just like the image classifier. With the image classifier, the input was an image, and the output was a label and confidence score. But here, instead of a label, we're actually going to get a list of XY pairs. Each one of these XY pairs will also have a confidence score. The reason why this is called pose detection is each one of these XY pairs corresponds to a key point on the body. So how do you know how many XY pairs there are and which ones correspond to which body parts? Well, it actually depends which BodyPose model, which pre-trained model you choose to use. There are two new pose detection models inside of ML5. One is called MoveNet, and another one is called BlazePose. They have some differences, there are some trade-offs, but the most important difference probably is that MoveNet gives you 17 key points on the body, and BlazePose gives you, I have to look this up, 39. BlazePose additionally can estimate a Z position. As you might guess, you might get some more accuracy, some more detail with BlazePose, but it might not run as fast or as efficiently as MoveNet. I'm going to mostly stick to MoveNet in this video. It's the default model that the BodyPose function loads. There's a one-to-one mapping between all of my old PoseNet examples and MoveNet, so it's really the one that I mostly find myself using. But towards the end of the video, maybe I can take a quick look at BlazePose, and I certainly would encourage you to give it a try as well. In my video about image classification in ml5.js, I spent a fair amount of time talking about the data that was used to train the MobileNet model. Pose detection is a perfect time for me to introduce to you another foundational data set in machine learning. This data set is called Coco, or Common Objects in Context. With ImageNet, every image was simply a picture and a label. The Coco dataset involves quite a bit more metadata for every single image. And it all has to do with this idea of context. Many images can't necessarily be identified as a single label. There might be multiple objects in the image. Where are those objects? Is there a body in the image? Where are the key points of that body? Which pixels inside of an image belong to which objects or which body? Another wonderful project that will help you learn more about the dataset is the Humans of AI website by the artist Philip Schmidt. The website includes an editorial essay which provides a lot of information and background around the history and data collection practices of this particular dataset, as well as a few different interactive artworks that allow you to explore the data in a novel way. I would also encourage you to read the original MoveNet blog post. It includes a deep dive into the technical details of how the model was made, as well as information on what data was used to train the model. You can see here, it used two data sets, Coco, as well as an internal Google data set called Active. I can't find any information online about this active data set to be able to look at it in more detail. If you can, please let me know in the comments. But this is not so uncommon to find a pre-trained model that is open source on some level in terms of how it works, but not necessarily making easily available all of the details about what data was used to train that model. I'm going to get to BlazePose later, but I'll also include a link to the original BlazePose paper, which covers a lot of the background details about that particular pose detection model as well. Finally, There are so many wonderful creative projects made by media artists that deal with the human pose. As I've mentioned before, this video is part of my class, Introduction to Machine Learning for the Arts at ITP, IMA, Tisch, NYU, and there is a syllabus page that goes along with it where you can find links to all sorts of creative projects. A couple that I would love to highlight are the PoseNet sketchbook by Maya Mann, as well as this recent project that just came out. I don't know that it's using MoveNet or BlazePose, called Olympic Letters by the artist Shar Stiles. All right, I'm ready to finally look at how does the code work to use the BodyPose model in ML5. So I'm starting with a P5.js sketch. I'm calling create capture to get a real-time camera feed from the camera. You can use MoveNet or BlazePose with single images. That's something I'll definitely include links to examples that do that below, but I'm gonna just start with real-time video. Note how I'm using the flipped true argument, again, to mirror my video. Finally, you'll want to make sure that you have the ML5 library imported in index.html. If you're just using the code I'm providing to you from this video, that will already be taken care of for you. Step 1, it is time to make a variable to hold the BodyPose model that we choose to use. What should I call it? Pose detector, BodyPose? Let's call it BodyPose. I'm going to use the preload function to make sure that the model is loaded before the sketch begins with setup. This is just like what I discussed in the image classification video. I am going to call, the ML5 factory function BodyPose that will load the model. Maybe I should be consistent in my naming here. Let's use a capital P. Once again, the model is being loaded from the cloud, presumably a Google server somewhere, but the images themselves that I'm gonna process through the model, that's happening on device in the browser on my laptop right here. BodyPose is like all the other ML5 models. You can call either a single function, detect, to look at one image one time, or another function, detect start, to initiate a detection process that happens continuously with something like a video. I'm gonna do this with video, so I'm gonna use detect start. I'm gonna tell it to detect continuously from the video, and then I need a callback function for any time that it has gotten results from the model. And now you can see, look at what's coming in. Object, 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 object. Now, I don't have a second person here with me, but one of the things that MoveNet and BlazePose and these models can do is detect more than one person. For the purposes of this video, I'm gonna keep things very simple and just always assume there's only one person appearing in the image. Okay, console logging the results is good, but in order to be able to use it more effectively to draw something in the canvas, I'm gonna wanna take those results and put them into a global variable. I'll call that poses. And I'm specifically gonna initialize the poses variable to be an empty array. This is because it's gonna take some time for the model to load. It's gonna be somewhat imperceptible to us, but I wanna make sure I don't get any error like poses is undefined. So even right from the beginning, I'm just gonna say, hey, when this sketch starts, there are no poses detected. Then inside of got poses, I'm just gonna set the value of results, or the value of poses equal to those results. So now is the time when I want to go back to this diagram over here that shows me the index values associated with every key point that's tracking on the body. And I should say, this is not a skeleton that maybe mirrors something you might find in a biology textbook or some type of study of anatomy of the human form. This is a somewhat arbitrary set of points that was designed for this particular model and interactive media applications. But we're going to go with it. And let's see if we can take a look and find that array inside of this poses variable. So sometimes when a variable is being continuously set in draw, it's hard to console log it. A technique that I sometimes use is just add a mouse pressed function and just say console log poses in there. That way I can run the sketch. I can assume that it's detecting my pose right now. I can click and I've got the results just from that moment in time that I can now take a closer look at. So we see that there's an array. Inside of that array is an object. It's the 0 element of the array. Then inside of that is, whoa, all sorts of stuff. This is the key points array. This is the raw output of the model, 17 key points. Each point is an object with an X and a Y, a name and a confidence. That is something we're definitely going to use in a minute. But one of the things that ML5 does for you is it actually also gives you all of the points named as properties of the object. So for example, a good hello world starting point is for me to just look at the nose. I'll also point out there is a bounding box for the full pose, as well as a confidence score for the overall pose detected. But let's look at the nose. And let's say I want to draw a red dot on top of my nose. The first thing I need to do is make sure there actually is a pose detected, and I can do that by checking the length of that array. Let's make sure there's at least one pose detected. If there is, that pose is the first element of the array. Again, I could do some kind of loop here. If there were multiple poses, maybe I need to figure out which one I want to pick, but I'm simplifying things. I'm just going to say, is there at least one? Let's just take the first one. Then I can get the X position of the nose by saying, X equals pose dot nose dot X. Same for Y, and I can draw a circle right there. We can make it red, and there we go. Wait a second here. That nose is on the opposite side of me. I forgot something very, very important. Remember when I said, hey, let's create capture video. Let's make sure it's mirrored. This is something I talked about in my other image classifier video. The model itself also needs to know that that image is meant to be mirrored. The P5 flipped property mirrors the way the video is drawn, but not the underlying pixel data. So I need to add also flipped true. And there we go. I'm drawing a red dot wherever my nose is. You can see that it's a little bit jittery. It's moving around quite a bit. Here's a little exercise, thought experiment for you. What if you used the lerp function, linear interpolate, I must have a video on that somewhere, to smooth out the motion of that particular dot. Give that a try. I'll include an example linked in the video description for how to do that as well. Another thing you might try right now is draw some more dots at other points. How do you find those points? By their name, get the XY position. Maybe you're going to draw different colors. Could you put a hat on somebody based on kind of guessing where it should go based on the eyes or the ears? All sorts of fun things you could try. I want to look briefly at what it means to iterate over all the points, just so you see what that looks like. So I know the pose has a variable called keypoints that has all the points. So here's a for loop that starts with I equals 0 and goes all the way to the length of the array. And then I'm looking at each key point one at a time. Presumably that means I could, let's make them blue, draw a circle at that key points X and the key points Y position. All right, what's going on here? There's all these extra points. They're jittering around. What? I don't have that. What's happening? Well, the video is only showing me from, approximately right here up. But the model, no matter what, is trying to find all 17 points. And those 17 points have to be somewhere within the canvas, within that 640 by 480 rectangle. This is where the confidence score really comes in and really is important. So this point that it's like guessing is some part of my body. It probably has a really low confidence score because it can't actually see it, so it's having to make a guess. So this is something you might want to think about when you are detecting poses. Is there a confidence threshold at which only then will you consider that point a valid point on the body or a valid pose overall? For example, I could say, if keypoint.confidence is greater than just 10%, 0.1, then draw that blue circle. And already here, you can now see that, I'm only seeing the shoulder points and the points on the face. Now, if my hands come up, we've kind of got the right hand and the left hand maybe is appearing, maybe it's getting my elbows, but you can see the points are only appearing if it's got a certain confidence. The MoveNet model is really meant to look at full body poses, and generally speaking, you want to be 5 or 6 feet away from the camera. Luckily for me, I have another camera over here, which I will now bring in and point this way. Who knows how this is going to go? There is a way in the code to specify which camera you want to use. Maybe I can include some information about that, but for me, it's often easier just to change the settings in the browser itself. See, it's pointing over at the whiteboard over here, and now I should be able to go back over here, get on this little step stool that I have positioned, And I can't see what it's seeing because I'm too far away, but I'll just move around. And I assume you're seeing more of the key points along the body. I hope so. Now, a lot of times if you're looking at demos of this particular model, you'll see that there's lines drawn in between the points. These aren't actually part of the model output itself, but it is useful to know which points generally should be connected to which other points if you're trying to draw the full skeleton of the body. And you can get those connections with a function called getSkeleton inside of the BodyPose model. I'm going to call that connections. And then in setup, I'm going to say connections equals BodyPose getSkeleton. Let's console log those connections to take a look at them. You can see that it is an array of 16 things, and each one of those things is an array of 2 things. So array index 0 has 0 and 1, and index 1 has 0 and 2. Those are the index values of the connections of the key points. Meaning, I could write another for loop to go through all the connections. And I could say essentially A is connection index 0, and B is connection index 1. And then what do I want to do? I'm going to say key point A is the pose key points, index A. Key point B is the pose key points index B. And then I can draw a line. Let's make it green. Make it a little bit thick. And draw a line between key point A, XY, and key point B, XY. Okay, let's see if that worked. There, now you can see all of those connections are being drawn. It's very far away for me to see a preview of this, but I kind of think that it looks to me like the points are actually quite a bit more stable. So there's gonna be less noise, less jitter on the points themselves if it can see the full body pose. And I can switch the camera back, and now I can see. Oh, I didn't. So I used the confidence score to only draw the key points themselves if we had a 10% threshold, but I'm not using that threshold for the skeleton connections. So that's an interesting little exercise for you. How would you have an if statement in here to only draw those connections if the confidence of the key points is above a given threshold? The connections don't have a confidence, only the key points. But I'm going to comment that out for now. So something that is a common technique for working with BodyPose is to use the P5 distance function. Let's say you wanted to detect if somebody is clapping their hands. Of course, we could use sound for that, and maybe actually later I'm going to show you a particular model that looks specifically for hands and gives you a lot more detail about a given hand. But even with this, we could maybe look for when the distance between the hands is small versus big. So let's get 2 points. I'll call them Rx for right X and Lx for left X. And it's actually the wrist, which is the key point that MoveNet is tracking. So I've got the right wrist in Rx, Ry. And I've got the left wrist in Lx, Ly. Let's draw a dot for each of those. So you can see left wrist is green, right wrist is blue. Let's calculate the distance between those 2 points. Well, I know. Let's change the size of the dot on my nose based on the distance between the hands. I'm just going to literally make it the raw distance right now. Let me jump over there to see if it's a bit more accurate if I'm further away. All right, let's give BlazePose a try and look at the differences. So I'm going to comment out all of the individual parts right now and go back to drawing the full skeleton and all the key points. Let's add that solution of not drawing the lines if the confidence is too low. So now I have the confidence of the 2 key points about to be connected in confidence A and confidence B. I can check to make sure both of them have a threshold greater than 0.1, the same threshold I used before. Let's switch the model to BlazePose. It's as simple as changing the string in the constructor. And suddenly, look at that, many more points. Seems to be running just as fast. Let's take a look at the full body. I can't really see, but I'm assuming this is showing you more points. There should be 3 points on the hand. There's also more points on the foot. I don't know if you're seeing that or not. There we go. Okay, don't hurt yourself, Dan. Sorry to interrupt, Dan, for the future here. Right now, I'm recording a separate video about how to work with the 3D key points from the BlazePose model. So if you're interested in that, be on the lookout. Out very soon, maybe even right now, depending on when you're watching this. All right, so that's the BodyPose model in ML5. MoveNet, BlazePose. There's a lot more properties and different things you could explore if you read the full documentation on the ml5.js website. I'm very curious to see what kind of creative applications you could come up with. And stay tuned. In the next video, I will look at the hand pose model, which will be very similar, but instead of the full body, we're going to get lots of detailed key points on the hand. See you next time.